Hello everyone, my name is Matteo Gramuglia, and in this video we'll go over the main points found in the paper Two-Layer Adaptive Funnel MRAC with application to the control of multi-rotor UAVs. The objective is to expand the current state-of-the-art of funnel control by enabling the regulation of the funnel diameter by means of some user-defined adaptive law and by means of the two-layered MRAC technology. Also, the objective is to employ the device algorithms to control a multi-rotor UAV and test their effectiveness. Now we will briefly go over the main points of Adaptive Funnel MRAC. So here we have the plant model and the reference model, which are linked by the matching conditions, which ensure that our plant is able to follow the reference model. Then we define the constraint set where we have the h function, which must be greater or equal than 0, which is related to the funnel diameter in this way, in which there is the eta function, which comes from the adaptive law of the funnel diameter shown here, that depends on the adaptive rate gamma fun and from xi, which is a user-defined function for regulating the funnel diameter, that in this case is built taking into account the control effort. And as you can see in the adaptive law for the final diameter is computed if and only if those two conditions are met. And in those two conditions, we also see the VE function, which is the barrier function, which depends on P, which as usual comes from the solution of the Lyapunov equation. And so, having defined all of this, we can define also the control law, which depends on the adaptive gain k hat, which comes from the solutions of the adaptive law shown here. Proceeding in a similar way, we applied the adaptive funnel formulation also to the two-layer MRAC technology, and the differences with respect to the previous slide are the red blocks that are highlighted here. So the adaptive funnel MRAC and the adaptive funnel two-layer MRAC formulations are compared with their counterparts, their classical versions, which are classical MRAC and two-layer MRAC. And the numerical simulations have been executed in the high-fidelity environment PyChrono. So to challenge the device control systems, the following mission has been devised, where the UAV needs to follow a user-defined trajectory and keep its roll axis tangential to the trajectory. And then after 4 seconds from takeoff, there's a motor failure, and after 7 seconds from takeoff, the payload is dropped. So in the next video, you'll see the numerical simulations employing the classical MRAC controller. In the next video, we'll see the same numerical simulations employing the adaptive funnel MRAC controller. Here we're showing the L2 norm of the trajectory tracking error, and as emerged from the video, MRAC controller in blue is much more prone to be affected by events such as motor failure and payload dropping, while funnel MRAC, shown in red, is much more resilient to those kind of uncertainties and events. As well, here we're also seeing the comparison with two-layer MRAC in green and its adaptive funnel formulation in black. And as we can see, even in this case, there's a improvement by employing the adaptive funnel formulations. And as well, we can see that the two-layer version, it's already performing much better compared to its classical MRAC versions. Here we are looking at the total thrust, and so this is to show that the better performance obtained by the adaptive funnel formulations and by the two-layer MRAC technology are obtained without the expense of having a higher control effort. In fact, all the control efforts are relatable. For more information, please have a look at the paper or feel free to reach out to us. Thank you for your attention.